Hey guys, Mr. T here. This is just me doing a video on a reaction between hydrochloric acid and sodium thiosulfate, otherwise known as hypo solution. Now this is the completion of the reaction, because you are going to be designing an experiment that tests the effect of different aspects on the reaction rate, say temperature, agitation, or what was the other one? Concentrations. So this is the base reaction, which I showed last week, but a lot of people missed it, so I'm recording it so no one misses out. So I need a thermometer, a pipette, a small conical flask, this laminated piece of paper with an X drawn on it. You don't get these for your group, but I'm showing you these here because during the practical, the way that you pour out into these measuring cylinders is with a large amount of the hypo and the hydrochloric acid in these things called freakers. These are used because they've got a lip on the edge, so it's easy to pour into a smaller thing like the measuring cylinder. Here, this beaker you only use if you are testing different temperatures effect on the rate of reaction. You would put hot or cold water into here, and then you would heat up your measuring cylinder of conical flask of hypo solution in that. You won't heat the conical flask directly. And then a stopwatch as well, because that's going to be what you use to measure the reaction rate, the time of reaction. The faster the rate, the quicker the reaction time. So, what do I mean by this reaction? How do I know when this reaction has started and when it's ended? Well, that I will show you now. So, firstly, for this reaction, you'll get 3 milliliters of hydrochloric acid. You're going to get that by using the pipette and extracting it from the freaker. So squeeze the pipette first, extract it from the freaker, and then squeeze it into your measuring cylinder. So this is a small measuring cylinder because you only need 3 mils. So almost there. I'm not measuring it super accurately, that looks pretty close to 3 mils. In this experiment, and something we discussed last week, was the idea of the meniscus, because you can see here, when you pour water in a glass container, it clings to the sides of the glass container. You have this dip in the middle. So you can see that dip is at 2.8 right now. The way that you measure in chemistry is that the bottom of that dip, which is called the meniscus, has to be at the line that you need. So we need a little bit more to get the meniscus up to the 3 mil line, because that's what the actual measurement is that we want. And you're going to be marked on saying how you control the quality of your experiment. So I would expect people to discuss the meniscus. So you can see that's too much now, so I'm going to extract a little bit from the measuring cylinder. Yeah, there we go. The meniscus is touching at 3. So I've got my 3 mils of hydrochloric acid. Now I need 25 mils of hypo solution. So pour that into the larger measuring cylinder. This glassware has all been pre-rinsed. It's really important that you make sure the glassware is very clean, because you don't want the reaction to start before it's actually ready. So that's gone over 25 mils. I can't angle it properly because the iPad is at an angle. So I'm going to remove some to get it down to 25 milliliters. It's just a bit under, but I'm just doing this for the purpose of example for people that missed out. So my reactants are ready. What I need to do first is pour the hypo solution into the conical flask carefully. Then measure the temperature of this. We need to know what the temperature of the hypo solution is, and what the temperature of the reaction is going to be without doing anything to it. So basically room temperature. So give the thermometer a minute to stabilize. I won't go all the way. I won't leave it the whole time. It looks like it's 19 degrees. because I want to show you the reaction. So let's say it's 19 degrees. I'll record that in my practical. I'm right up, and now we'll place the conical flask on top of the X. You can just see that from the video there. And what I do is, to start off the reaction, you need to pour this hydrochloric acid into the conical flask there and immediately start the timer. What happens in this reaction is it creates this compound that's cloudy white. And over time, as the reaction progresses, more and more of this white compound appears, and it will eventually block out that X, which will be our marker for when the reaction has finished. Now, to keep it controlled and to get the reaction started, once we've poured that hydrochloric acid in, we also want to swirl it twice and keep that consistent across trials. So, to show you the reaction, pouring the hydrochloric acid into the hypo solution, quickly without spilling it, 2 swirls, and start the timer. And so over time, this is our control experiment, so we haven't done anything. This is just a base reaction. No temperature, no extra agitation, no weird concentrations. You can see that the liquid is becoming cloudier over the reaction, and we're going to stop the timer when the X disappears, which is now. So you might have looked like it disappeared a bit earlier on the video, but that's because you're looking at it from the side. I was seeing it from the top where it's a bit easier to see, but it has stopped at 30 seconds, 9.9 milliseconds. So that is the base reaction. What you are going to do, what you're going to be marked on, is designing an experiment that's going to test the effect of different variables that could speed up or slow down the reaction time. So it could be reaction temperature, so I could heat up some water, put it in here, and then put the hypo solution in there to make it a bit hotter, and then run the reaction and see if it happens faster or slower. I could put icy water in there, see if the cooler temperature makes the reaction happen faster or slower. I could swirl 1, 2, 3, 4, 5 times, like multiple times, and see what the effect of agitation is. And the other thing I could do would be changing concentrations, because you'll have a range of different hydrochloric acids concentrations available. Okay, so that is the base reaction. Now you need to go back and have a think about what method you would do to test the effects of different variables on reaction rate. Alright, so I'll see you on the next video.